This is going to be our first of a few of Unit 1 videos going over the basics of Algebra 2, getting you ready for the deeper stuff that we're going to be doing. So let's take a look at a graph here. We got a typical polynomial graph, and we're going to examine first the domain and range, the domain being all its x's. So we're going to write this in interval notation. Since it goes without bound to the left and the right, we know that our domain is going to be all real numbers. Our range, well, it looks like it bottoms out at -4 and it goes all the way up. So we're going to have a bracket with a -4, that's inclusive, and it goes into infinity on up. Now we're going to look at our intervals where it increases and decreases. We'll take increasing first. One of the first intervals looks like it's going to be right about here. We have a point where it changes directions here, and it increases right through here. So from here to here, it's increasing, and I'm going to call that -2.4. I'm going to use parentheses because we're not going to include the about -1.5. -1.5. I'm just getting close enough for grammar work. We're not going to include that point because you'll get into some of that in your upper level classes. How the tangent or the slope can be instantaneous at that point. And then goes up to 2. Again, not including it. And it also goes from about 4.2. And again, I'm just guesstimating on the exact one because I don't actually have the function in front of me, to infinity. So that's the intervals where it is increasing. Decreasing, we're basically going down here. If you want to think negative slope relationships, you can do that. And it starts off with a -infinity and going to about -1.5. Again, I don't have the function, so I don't know the exact value of that point. And it decreases from 2 to about 4.2. All right. Now, average rate of change. Let's take, for instance, I'm going to do an average rate of change of, say, between the interval of 0 and 5. I'm going to take the average rate of change of this. Now think about when you're driving in a car, you're going on a trip, say to West Texas or East Texas or something. You're going to hit traffic, you're going to slow down, you're going to speed up, and your graph is going to be very inconsistent. But you're going to only have one overall rate when you get there. Say it took you 4.5 hours. To get somewhere, and you can look at, well, I averaged about 52 miles per hour. That is just your average rate. We're doing the exact same thing here, so I'm going to do from this point to this point, and all I'm going to do is just use the f of x, and I can distinguish them, and I am using the f of x notation as long as I'm in order. Normally it's delta y over delta x, which is still, equivalent. So my f of x of 0 is -2, and f of x of 5 is 0. And my x1 is 0, and my x2 is 5. So -2 minus 0 is -2 over -5, so I got 2/5 is my average rate of change. And behavior, right now we're just looking at the very fundamentals, but end behavior is going to be pretty important in predicting some of the graphs, what kind of graphs we have. Like, for instance, I know that we have something that is x to the 4th based upon my own experience, because I have 3 zeros. We're missing a 0 here. We'll learn about the fundamental theorem of algebra shortly. And they both point up. So that means that if they both point up, I must have an even exponent on my leading coefficient. And I also know that a is positive because this opens up. So what we're going to do here is go ahead and do from as x approaches positive infinity, f of x approaches positive infinity. Okay? And as x approaches negative infinity, f of x approaches positive infinity. This is going to again come into play much later when we start analyzing the properties of graphs. We just want to have our basic concepts down. So that is it for this. I'm going to save it, upload it, and do the next video.